Welcome. In this video, I'm going to demonstrate how to determine whether this power series is convergent or divergent. And the series we're given is x to the n divided by n factorial. We are going to use the ratio test. And recall the ratio test. We have the limit as n approaches infinity of the nth plus 1 term divided by the nth term. So that's the next term divided by the nth term. And we're going to call this L. If L equals 1, the test is inconclusive. If L is less than 1, the power series converges. If L is greater than 1, the power series diverges. All right, so this little aside here in purple, let's use that. The nth term is x to the n over n plus 1. Excuse me, not n plus 1. What am I doing? N factorial. There we are. And the nth plus 1 term, that's x to the n plus 1 power divided by n plus 1 factorial. Now let's take a look at our limit, this ratio of the nth plus 1 term. So that's x to the n plus 1 divided by n plus 1 factorial, and this whole quantity divided by x to the n over n factorial. Now we're dividing a fraction by a fraction, so let's multiply by the reciprocal of the denominator. So that is, if you have a over b divided by m over n, this is a over b times n over m. So I just flipped the denominator fraction and then multiplied. So we have the limit as n approaches infinity of x to the n plus 1 power divided by n plus 1 factorial times n factorial divided by x to the n power. Oh, and let's not forget this absolute value here. Thank you. Okay. So really quickly, let's chat about what n factorial is. This is n times n minus 1 times n minus 2, and you keep multiplying and subtracting until you get to 3, 2, 1. Here's some examples. 4 factorial is 4 times 3 times 2 times 1, that's 24. 5 factorial is 5 times 4 times 3 times 2 times 1, that's 120. So see how each time I just multiply by the previous number subtracted by 1, or the previous number less 1. Okay, so what is n plus 1 factorial? Well, that's equal to n plus 1 times n plus 1 minus 1 times n plus 1 minus 2 times n plus 1 minus 3, and so on, and I'll keep going until I get to 3, 2, 1. Simplifying, well, there's nothing to simplify here. N plus 1 is just n plus 1, but n plus 1 minus 1, well, that's n. And then n plus 1 minus 2, that's n minus 1. And the next one's n minus 2. And what do you notice? That is, what do you notice here? If you said this equals n factorial, you are correct. So really, n plus 1 factorial is just n plus 1 times n factorial. So let's go ahead and replace that here. Okay, you can see I rearranged my screen before I continue, just to make some space. Those of you on paper, just keep writing how you were writing. If you're on a tablet, if you'd like to pause and take a moment to rearrange, that's fine. Otherwise, just keep writing how you were writing. So this is the limit as n approaches infinity of x to the n times x to the negative n. All I've done is split this into the product of x to the n times x. And then this x to the n, I can move it to the numerator by making the exponent negative, which I did here. Oh, and of course, times n factorial divided by n plus 1 times n factorial. And so, of course, n factorial divided by n factorial is 1. And then here we have x to the n times x to the negative n. That's just 1. So we end up with the limit as n approaches infinity of x over n plus 1. All right, so this is, well, this limit here is concerned with n's, not so much with x's. So I'm just going to pull out this absolute value of x to the front, and we have the limit as n approaches infinity. And then here we just have 1 over n plus 1. And of course, since on our series n can't be negative, there's no point in keeping an absolute value here at all. Well, this limit here is going to be 0. And that is for whatever value of x we have, since 1 divided by n plus 1, and n is growing without bound, so 1 is going to be divided in essence by a very large number. That gives us 0. And 0 times anything is just 0. So this power series converges for all real numbers. Remember, R is all real numbers. The radius of convergence, R, is equal to infinity, and the interval of convergence is just all real numbers, which is negative infinity to infinity. If you have not seen this notation before, here are several ways to write it out equivalently, all real numbers. You can use this symbol, or you can write the interval from negative infinity to infinity. All right, hope this video made you feel like you're writing on rainbows.